motion and speed is acceleration. The definition of acceleration is the rate at which velocity changes. So how quickly is the object slowing down, or how quickly is the object speeding up? Acceleration is going to occur if you change your speed. It also is going to occur if you change your direction, because remember, velocity changes if we change direction or speed, or acceleration happens if you change both. So if a car speeds up, it's accelerating. If a car slows down, it's accelerating. If a car is turning corners, it is accelerating. So anything that's speeding up, slowing down, or changing direction is going to be accelerating. So when we calculate acceleration, we're not only looking at how much that velocity is changing, but how quickly it's changing. Most difficult equation up to date. It's honestly one of the most difficult ones we do all year because it has four different variables within it. It has acceleration, final velocity, starting velocity, and the time it takes to change the velocity. So first off, units. We use meters per second per second. So we are calculating how many meters per second it changes every second. So a simpler way to write this is meters per second squared. You can write it as either way, but I have it written there. Circle it for you here if I get my pen. You can either use meters per second, or again, sorry for that awful circle, or meters per second squared. So an example problem I have here is an object is starting off with a velocity of 1 meters per second south. So it's starting off going 1 meters per second. The final velocity is 5 meters per second south. And it takes 10 seconds for it to do this. So at second 0, it's going 1 meter per second. At second 10, it's going 5 meters per second because we know it's 10 seconds. So we take final velocity minus starting velocity, which is, in this case, 5 minus 1. So that gives us 4. And then we divide it by time. So 4 divided by 10 is 0.4. And you can write either meters per second or meter per second squared. So essentially what this tells us is that object's velocity is going to increase in the southward direction, because we know our velocity is south, by 0.4 meters per second every second. So every second that object travels is going to get faster by 0.4 meters per second every single second. That's what acceleration is. So that is what that is telling us when we calculate our accelerations. Examples of acceleration. First off, a plane taking off. It's changing direction by going upwards. It's speeding up. A car stopping at a stop sign, it's changing its speed, it is slowing down, it's decelerating. It has a negative acceleration because it is slowing down, but it's decelerating, which is a form of acceleration. If you are jogging on a winding trail, even if you were going at a perfectly exact constant speed, you are still going to be jogging on a winding trail. When you're doing that, you're still going to be changing your direction, which means that you are accelerating. Same with driving around a corner. No matter if you're at a constant speed or not, it's changing direction, which means you're changing velocity, which is a form of acceleration. Like I just briefly mentioned there, you can have positive or negative acceleration. So most of our calculations we do, you're not going to get a negative number, but in this acceleration you can. If you are increasing velocity, it's positive acceleration. If it's speeding up, you're adding speed to that velocity, so that means you're getting a positive acceleration. If the object is decreasing in velocity, so it's slowing down, like a car stopping, or if at the end of a run as you slow down, you're decelerating, so you're slowing down that motion. You're taking away speed from that velocity. So that's a negative acceleration. So if something slows down, when you do these calculations, you will end up with a negative number. Centripetal acceleration is something that occurs when you have an object moving in a circular motion. If you've ever taken a bucket of water and spin it around in a circle, going upside down, and that water doesn't come out, that's because of something called centripetal acceleration, because that bucket is constantly changing motion, which means it's constantly accelerating, and it's allowing that water to, because it's always changing motion, it pushes that water essentially against the sides of that bucket rather than letting gravity take over. while we're talking right now, to get full credit for these notes, go ahead and draw a circle next to the centripetal acceleration title so I know you know what we're talking about, just to make sure you get full credit for these notes. Alright, and the last thing here is acceleration on a graph. So again, we looked at graphs with speed and distance for velocity. Here we're looking at how velocity changes over time to try and find the acceleration. So again, we'll do these practice problems together. I just wanted to show you here real quick how to read one like this. So for example, if you asked what was the acceleration of this object at 4 seconds. So at 4 seconds here, we need to find, sorry again, with this pen is not my friend. At 4 seconds, we can see that this object is going at this point, so it's at 12 meters per second. So after 4 seconds, it's going 12 meters per second. So we know our final velocity, if we're using 4 seconds as the case, our final velocity is 12. Our starting velocity, so at second 0, was 6. So if we do final minus starting, so in this case 12, which we'll have as our final, and 6 is starting, which we'll sometimes call initial. So 12 minus 6 is 6, and you would take 6 divided by 4, which is our time, because we do final minus starting divided by time. So 6 divided by 4 gives you, I believe it's 1.3, and it would be 1.31 meters per second squared. So again, that was a quick overview, but we will get into that more when we're doing some practice just to show you. But we'll make sure we do plenty of practice problems with acceleration.